Today's AI and machine learning algorithms are nothing short of revolutionary. They've automated complex decisions, once the exclusive domain of human expertise, with astonishing accuracy. From healthcare diagnosis to financial forecasting, these algorithms are reshaping industries. However, the brilliance of these algorithms is only as good as the data that they're trained on. When this data is imbalanced or skewed, the algorithms can inadvertently introduce discriminatory biases. This affects the fairness and impartiality of decisions made by the AI. For example, a loan approval algorithm trained on data from a predominantly affluent neighborhood might unfairly reject applications from less affluent backgrounds. Well, NLP, natural language processing models, are a subset of AI that's gaining traction across a lot of areas like resume screening, college admissions, emotion assessment, even predicting criminal recidivism. NLP is expanding rapidly, along with its potential for harm. The role that these models play in reinforcing societal biases cannot be overstated. Bias in machine learning manifests as unwarranted associations between attributes. For example, if an NLP model used for college admissions correlates the name Emily with higher academic performance, because it's demonstrating bias. These attributes, names and academic performance, shouldn't be correlated, yet the model might make that association, potentially affecting admissions decisions. And as we integrate AI and NLP models into more facets of life, it's crucial that we scrutinize their potential for bias. But now the question becomes, how? How can we see bias in an existing model? Can we learn how to build models without bias? Well, thankfully, these are not new questions for today's guests. Charlene Ulrich, she's lead data scientist, as well as Daniel Cholakov, principal, both in the management consulting group here for WWT. Today's discussion centers on this worldwide technology paper, Mitigating Bias in AI Using debias-GAN. It's a fascinating look at using AI to deal with, AI. Our discussion centers on the nature of AI biases, techniques for bias detection, as well as strategies for bias mitigation in machine learning models, because it's a technical challenge and an ethical imperative. Thank you for joining us. My name is Rob Boyd. This is WWT Research, insights powered by Worldwide Technology and their Advanced Technology Center. Hey, welcome to the show. Thank you so much for joining me. Let's go through some quick introductions. Charlene, we'll start with you. Who are you? What do you do?
Hey, hi. I'm a lead data scientist with WWT. So basically, my title is data scientist. I always find it's hard to explain. I'm a scientist, but I deal with data. But on the other side, I feel I'm also a consultant, so which we help clients to solve their specific problem and deliver AI models to the clients.
Got it. Yeah. I figure you guys both may be somewhat in this category of when you go to explain to people, what do you do? You're like, well, do I give you the data scientist speaking to data scientist description? Because that's completely different probably than just the generic cocktail party where you're not sure what anybody does. But either way, Charlene, glad to have you here. We'll dive more into your expertise in just a moment. But Daniel, do you mind introducing yourself and what do you do for Worldwide Technology?
Yeah, just to confirm that recognition of data science really improved in the last 12 months. From my wife asking me, how do I explain to other people what you do, to now other people explaining to me what I do. So it's kind of easier. So I'm in the management consulting team in Worldwide Technology, and I've mostly been on data science projects, but also some security and cloud projects. And it is that wide perspective we get at WWT that makes the work fun and gets me right back into data science and how the environment matters around that.
Gotcha. But you're connecting people to solutions and helping understand, translating, if you will, between different groups, I'm sure. But both of you are very valued on this show. We're talking about bias in AI and specifically some based around a study that was shared with me around how WWT has been building models to address some of the issues. And it is just a sliver of what's being done there. And we'll talk about that more later. But let's just focus on bias here for the moment. And I'll ask a generic question. When it comes to bias, what is it about bias and these models, these AI models that are really taking off right now? What's important to understand about bias and AI?
Yeah, well, so as we all know, like AI is playing like bigger roles in our daily lives as companies and organizations. They try to make these data-driven decisions. In on the other hand, people start to realize there can be bias in their data and also in their algorithm. And if we know there's a bias, we know bias is not good. We should look into that problem and look into how we can mitigate that.
We don't want to build models that are biased in some sense, like in a general sense, because they may not do the right things for the business or for whatever purpose we're building in society. But also in a very specific sense that some part of the community may be misrepresented or not treated in the right way. The type of people that work on the team care about these things by first principles, but our customers care as well, not just for doing the right thing, but also from a compliance perspective, risk perspective. If you don't deal with bias and various responsible AI risks upfront, you might not even do a data science project. You might not even adopt the latest AI, like large language models and whatever is in the news right now. So to be at the cutting edge, to do technology right and fast and to get value, you need to deal with bias.
When we build these models, we have to use pre-existing data. And one of the challenges is that data, even though it could be extremely broad and maybe even very diverse, we're not always in control of what patterns get picked up by the model as it's learning or as it's developing the algorithms. And the problem is it seems like we have to base stuff on historical data because we can't base it on data that doesn't exist yet. And that data may have implicit bias and things baked in. And so now we're almost, the model is simply picking up on things that are there. That it's not as if we purposely chose to have bias in the model. Am I correct in the way I'm thinking of that?
That's a good example, like we say, resume selection tools, which is like unintentionally inferior of, like, say, male. The reason is because historically it's more male that was doing that work. So, and the model kind of pick up that inferior of the man over female.
Yeah, there's been several public examples, right? Daniel, go ahead.
In the general sense, bias is always in our data sets. And I feel safer when I assume that upfront. The problem is I don't know what that bias is upfront. So that's where we need to think carefully about the specific situation. So Charlene gave one specific situation where society has discussed the problem actually quite a bit at length. So at this point, I would be a little bit embarrassed if I build a model analyzing resumes and it still has a lot of gender bias and so on. Now, I never expect the bias to be totally gone, but it should be better than before. Now, it can be different in other situations. If you are trying to track the performance of frontline workers in the extractive industry, in the copper mine, for example, by default, different people will perform in different ways. And if you want to help various groups improve, you better represent each of them in the training set. Except not all of them are represented equally. Actually, in the first place, you don't work with an infinite amount of people. You may work just with a few thousand or a few hundred. So even in a somewhat technical operational data set, like what I'm discussing now, if you think carefully about the problem, you will realize that biases should exist in the data set. And then you need to decide what is the real impact on the frontline workers, on the business, and how to deal with it. But the first question is always, I assume there must be some bias in my data, so let me just think through it.
Yeah, and so we're going to talk about how Worldwide has looked at how do you test for something like this, right? To be able to acknowledge that it's there, but then say, well, how do we deal with it? We are becoming more and more dependent on AI to the point that we don't realize AI is even playing a part in some of the decisions being made. And a lot of us, maybe people of a certain age, more so than others, myself, we've had this thing where you go, well, I don't know why you weren't allowed to do this. That's just what the machine told me, or that's what the computer spit out. And we have this kind of weird acceptance of something that came from a machine, forgetting perhaps that, well, that machine was programmed by flawed people. So I, as a flawed person, need to be very careful about accepting it at face value. But nonetheless, we're going to have lots of people that have to, right? Because jobs depend on the ability to rely on the data. And so you need to know that data has been looked at appropriately. And there's so many different ways to go about doing that. So let's jump into the research. WWT did research that I've now talked about on several different shows because I find it interesting that something that to me doesn't have an immediate monetary return is being invested in by worldwide technology. Why does WWT make investments in things like the research that we're here to talk about?
So from my personal perspective, it is, again, first principles, let's do the right thing. I mean, even if down to the level of let's have fun at work. It just happens that data scientists are the kind of people who are creative, who go out there, try new things. Even on Saturday afternoons, they would download some data set and play with it. Now, it would be great if that creates business value. Now, that's top of mind for me, but for the organization, what's top of mind is what our customers want to achieve. And worldwide technology is in a position where our account teams, our people out in the field, talk to clients all the time. CTOs, CIOs, people that manage data science teams, and they hear the new questions very fast. For example, like a few years ago, the topic of bias AI was larger. Now that topic has evolved quite a bit. I'm not going to go to the whole list of innovation in information technology. Let's say focused on bias, because the next question is, if our clients are going there, they're clearly not being served well today. This is new. So should we get in front of the problem? And out of everything that we could invest in, what are the problems that will be most important for our clients 2-3 years down the line? And that's the point at which you decide to invest. Now we have a standing research and development program within the data science team, but innovation is a culture across WWT as well. There are other explicit, direct ways to create innovation. So the research we're going to discuss today is part of that specific R&D program within data science.
Charlene, this debiasing AI, I think using GAN models or debias-GAN. Can you explain what the research project was about and kind of how it was approached?
So first I'll start, we are data scientists, and also we are consultants. So we help our clients to deliver, implement AI models. So there are three things we all care when we deliver the models, the accuracy, the explainability, and also fairness. So in this paper, we more focus on the fairness. First, we look into how do we measure bias or fairness. We can't solve the problem if we don't know how to measure it. And then we are picking a data set. It's a Twitter data, and it's related to the ethnic groups. And we try to classify that tweet is conversational or non-conversational. So it's not necessarily saying conversation is good or bad. It's just something we can quickly to calculate our fairness metric, and then try our mitigate technique and see if we can get the result improve in the fairness.
To be clear, it's not about trying to solve something for the company formerly known as Twitter, but it's more about the fact that that was an available data set that also had some things that could, when you talk about conversational versus non-conversational, those are proxies, I guess, for saying, can we recognize certain things? In other words, is there a relationship I can see as a human that I could then use to test the algorithm against?
Just to make the direct link, so instead of conversational, we could have asked something about gender, or something about ethnicity, or something about the class of employee. It is all about representation, but in this specific case, it's conversational versus not. It's not something that we may care about in terms of bias in everyday language, but it is something we had data on, and we could prove the concept.
Which goes to, and I meant to point this out, but Charlene, you mentioned that one of the tenets that you guys follow is explainability, which I feel like is not something we get too much of in this field, because it's all that, you hear senators, you hear enterprise leaders, you say, I want to look under the hood. How are you coming up with these results? You go, well, it's not that simple. We can't just look under the hood and poke around and see how these things are coming out. But explainability is a key tenet of what you guys are constantly working towards. Is that correct, Charlene?
Yeah, it's the other field we are also with research focus on.
Excellent.
But yeah, it's a kind of different metrics we are evaluating the AI model.
Okay, well,
yeah, and the concept from in a general perspective applies a little bit here as well. But just to confirm that explainability does have multiple layers. It starts from the very beginning of getting the data set, understanding what's in it. and asking some very simple questions. I mean, they can be about gender, ethnicity, conversational. And this can be as simple as throwing a few graphs in a Python notebook for a data scientist, or a business intelligence tool for a business leader. Anyone can start building hypotheses based on seeing the data for the first time. And then it's up to the data scientist to maintain that philosophy, that approach to the data and the model throughout the process. Now, Rob, as you mentioned, as you implied, it's not always possible. You cannot figure out what every neuron does in a 100 billion parameter model, but you can keep prodding at it and putting it under different situations. So explainability is possible throughout the process, just not perfect. We better have some idea of what bias looks like before we try to solve it. So at least we need to explain what's in the data to ourselves so that we can find the right tools.
Well, let's talk specifically about GAN models. And Charlene, can you explain what a GAN model is and how was it, and then branch into how it was used in this specific use case?
It's a generative model. The full name is like generative adversarial networks. Basically, it has like two neural networks models. One is called generator. It's generate like synthetic data. And the other one is called discriminator. It tries to tell like what generator generates is real or not. So by training both network, the generator will end up generate like a realistic data.
Do I understand correctly that the generator was kind of being built to generate ethnically oblivious tweets, which in the parlance of what you're doing here, it was about conversational or not, correct?
In the data set, we see like within the two ethnic groups, there's a difference in the ratio of conversational tweets. We try to use a GAN model to generate more synthetic data, like say race, oblivious. And then we try to use the data to train our classifier and see if we can improve the fairness metric.
Somebody who is trying to do the right thing, let's say in this case it may be me, and I can constantly generate sentences that I think make sense.
Right.
And in this specific case, maybe they're not ethnically charged, for example. But Charlene, as the discriminator, can say like, yep, that was okay. No, this sentence was clearly ethnically charged. And I as a generator, I don't have a moral view on things. I just generate things. Okay. But when I hear from Charlene that she identified some bias in something I did, I would then continue my training, my implicit brain training, until Charlene can discriminate less and less. Like she can find less and less bias in what I say.
Okay, so I'm going to try to put this in my own English. It's two models, one of which is being used to say, yes, that you built something that was good or not, and so you get and if I understand also in this, the way you guys did it, there's a reward, and not necessarily a penalty, but the penalty would be a lack of reward, I guess. The discriminator is constantly saying, how can I feed back the success of the generator so the generator then can improve upon its ability to do this? But the idea is to constantly throw something at it and see if you can fool it, because that's going to help you understand if the model is improving.
So yeah, although I think I only explained what GAN model is, but in our paper, we call it debias-GAN. It's built on top of the same idea, but we have more models, neural network models in the system. So we use like a large language model to generate some like a token probability. And then we have the generator, which is just to pick from those like tokens. We call the policy gradient. And we use two discriminator. So one is see if it's generate like tweets look like tweets, and the other one is try to remove the protected attributes in the tweet. So we have two discriminator kind of use it to shape the data that generated to train our model.
And that was the thing, I think when I first read the paper, I was a little bit confused about if we were saying debias-GAN, just as the way it read on the paper. Was it about debiasing a GAN model, or was it about it's a specific framework that uses GAN as the overarching framework, and you guys have some unique models that fall underneath that in how you specifically addressed it with this Twitter data set?
Yeah, just in case GAN is listening to this show, we are not implying that GAN is doing something wrong. It's just a modeling framework. The bias The bias will come from the data and the way we use the model, but the model itself is just that framework we're speaking about.
That's the implication of the discriminator versus generator being used to kind of raise all ships and say, this is how we improve everything by constantly challenging it, learning from that challenge, what worked, what didn't, and tweaking. But that mystery of how that happens in the end becomes something interesting. Charlene, how do you test? I mean, what are the actual results? How do you know when you're done?
So we use like two various metrics. In this study, let me explain. One is called difference in equality of opportunity, which we will calculate the absolute difference of certain protected class between two groups. Let's say if in the man and male group, say we have predict a man to be a leader, how many men will be a leader, and compared to women, then we calculate that false negative rate of that classification, and we calculate the difference between the two groups. That's called is a DEO as one of measures. Differences in equality of opportunity. And then the other one we call the bias amplification. So which is measured like how much bias got amplified in our algorithm. So let's calculate the difference in predicted rate versus the actual. So the first one's kind of measure the biasness in our data, and the second one's like how much this bias got amplified in our algorithm. So with those two, we kind of can test how the model does, how our technique does, in terms of mitigate bias.
The idea of the debias-GAN approach is to generate that less biased data. After that, you can build various models with that. So what the team did is build at least one model and see how that behaves on some kind of bias metric. And the way I understand that is if we just take gender and leadership, in the underlying data set, maybe gender and leadership is maybe 55% of leaders are males. When you use the debias-GAN, it might get it more like to 51 to 49. 51% of leaders are men. Now you've decreased the bias, but you haven't totally removed it. And then when you build a model on top of that, the simplest model, if you make the simplest model you can imagine, you can ask it, hey, I'll give you a gender of a person. Tell me if this is a leader or not. And every time you give it a choice, it will always say like, yep, the male is the leader, the male is the leader. Now I only have a slight chance to be right, 51 to 49, but I'm going to abuse that chance as much as possible. And that's a bad model. So that's where the two stages, you can decrease the bias in the data, but it can still be way amplified in the model.
So the learnings that come out of something like this, and you build the actual model, does that make that model applicable to a different data set that could be fed into it? Or is it more frameworky than very specific in terms of where this is used? How is the learning applied?
So I think it's more of the framework we try to build. So it's like, the ML ops, we try to streamline all these operations. We can, test accuracy, and we can do iteration to improve model. And we hope something can become more automatic, can bake into the model training process.
You will be changing even the type of the data set. Maybe it's not tweets, it could be some long form language. So that one of the discriminators that Charlene spoke about was, does this look like a tweet or an X versus something else? Well, if you have a different type of data set, you wouldn't be trying to force the generated text to be tweets again. Yeah. Then you can change the metric across which you're seeking bias. So conversational versus not is just what we prove the concept on, but there are obvious other options which we already touched on. Gender, ethnicity are just a couple that come to mind all the time. And by the way, there's a good reason they come to mind. It's a social problem, but these are also protected characteristics in law in the US and other places. You can change what kinds of models you're going to build on these less biased or debiased data sets. So yes, it's a framework on which you do need to make conscious decisions as you apply it in different situations.
There's relationships that the algorithm is going to make that we may not have intended. But what we don't want to do is bake in the bias and make sure it's repeated as we move forward and, and consistently move backwards societally. Daniel, would you agree that enterprises, when they're looking at AI now, there's such a hype cycle. We've been using AI, and AI has been affecting resumes in many other places, criminal defendants and all kinds of stuff for years before ChatGPT came out and we get language models, large language models specifically. But in my opinion, enterprises are both excited by what this can do, but extremely hesitant about adopting certain things because it's just real unclear. Cybersecurity is the easy thing to name, but there's so many other potential risks that you're opening up to here that it becomes how do I go fast safely? Is this type of thing what Worldwide is doing to help enterprises, organizations, government, whatever it may be, move forward in a judicious manner?
Yes, absolutely. So reducing bias in your input data sets helps with your modeling, helps with what you implement in the real world, and that would be impacting your own employees or your consumers or operations. So yes, decreasing bias should increase trust in the whole data process. This is just one piece out of a larger puzzle. So yes, there is security concerns. AI can be attacked. There is also privacy concerns of the data that you put the data you input into the model. Where does it go? Who has access to it? Does it stay always mine? There are also more general responsibility concerns. Yes, a data set can be biased, but it can also has other issues like using foul language and other things you don't want to get in front of people. Yes, absolutely. Decreasing bias in data will help increase trust, but it is not going to make the whole process trustworthy. That requires a more general, responsible AI framework. You need a lot of expertise to be able to predict those issues, but also in the opposite direction, you need to free your mind and assume nothing, and then ask the simple questions so that you can start tackling those biases and those issues in general.
Charlene, is there anything else that are important to understand about the research?
As we did the research about regarding the bias AI, we actually learned a lot as a team. So there are many big tech companies. They have a framework that help people to practice to evaluate their model regarding the bias. And also we as a WWT consultants, we like to help our clients to achieve that model, the goal too.
Yeah, in another conversation, I'd heard it kind of explain that Worldwide approaches this also because it's about staying constantly educated so that you are at least in lockstep with your customers, if not, of course, ideally ahead so that you can lead them appropriately. But I know that you guys also learn a lot from your customers based on the way they push you, and some are going to be more aggressive. But the benefit from working with such a wide global customer base is you guys are working with some very advanced customers to do some very advanced things that may or may not apply to others, but it's still going to raise the knowledge level that gets applied across your other customer base because you guys have a lot of expertise in different areas, and it requires that. It feels like
one angle that we haven't touched on in the very beginning is the assumption that you are building your own model, that the assumption that you own the data. The easiest example is especially in the last several months with large language models. Everybody uses them outside of work, maybe at work, and you input a prompt, but the prompt you input is not even the data on which the model is trained. Right. There is a much larger data set. It may be Wikipedia, it may be the whole internet. You don't know. In fact, many of the companies that create those models will not give you access to the underlying data set. You cannot apply debias-GAN on a data set that you don't have.
Interesting. Okay.
But it still gives you the right to ask questions. What are the kinds of biases in the input data? What have you tried to measure? Did you even have the time to do that, or did you rush to push a product out? Out of what you tried to do, let me ask you a couple of smart questions. Did you try debias-GAN? Did you try to measure the difference between between how the model behaves when you tested it versus how the original data set would have behaved? The deeper the questions you can ask, the more you can engage with the data scientists who can either want to really show off what they have done, and they're going to give you even more depth about the way that they protected your data and your outcomes, or they may recognize that indeed is a gap. So please, when you use our product, please maintain this is a risk in your mind.
Yeah, use at your own risk kind of thing as well.
But we as users have the right to ask.
And we should, right? We need to be doing more of that. We need to not take everything at face value. How does a customer engage with Worldwide if they're not sure about how should I be looking at using AI responsibly, or perhaps I have a specific project that I think AI is going to play a large part in? Are you guys able to assist with thinking through how to do that and helping with the implementation?
If clients engage us, we probably first going to look into the data they have. We will always assess what is the business problem, try to solve, and we'll assess the data they have. And then if it's like a data issue, we always try to understand what the data try to tell us before we implement what model it is. I think we can help the clients try to just evaluate the data from the first step, and then we will see if we're able to collect more data. If not, we will think about the other more advanced technique to mitigate bias.
We are lucky that we work with very, very smart customers. So they often have very well phrased questions in terms of business outcomes, in terms of what they want to achieve, in terms of what they have already tried with the data science team, maybe even without the data science team, and where they would like another opinion or maybe even help. Now, from a technical perspective, that can sound half-worded or not quite clear, because we still need to translate that question into potential technical options of what could actually be improved. And that's where our team, the consulting team and the data science team, comes in. It is key to understand what the client has tried before, and also how wide the options are that the client is ready to consider. Now, Worldwide Technology has a very wide perspective. We have a wide perspective on the marketplace because we work with a lot of diverse vendors. So on the buy part of the decision, so can I work with somebody else? Has somebody else already solved my problem in a product-driven way? Or on the build direction, on the build part of the decision, how much should I be doing? Should I be building myself? Are there additional approaches that my team hasn't tried yet? Maybe they're too novel or unproven that my team could try, or maybe my team could try with the help of Worldwide Technology. Once we go through the width of buy versus build decisions, then we can go back to a specific proposal that WWT can make to help the client solve the problems that they have already phrased well.
Charlene, what's important to remember coming out of this conversation?
We not only love to help clients to implement their solutions, we work side by side with them, and also try to look after that potential things might happen in the model. So with the debias-GAN model, this is something we look ahead and try to think to be proactive.
This is just kind of one small example of what you guys are doing in other areas with AI. At the very least, I would imagine you've probably got multiple models testing different things, again, depending on what's next for clients and what needs to happen. But Daniel, any final comments from you?
I might do something unusual and unasked for, but I would like to suggest some homework for the audience.
Oh boy!
So if anyone anyone might just take 5 minutes and a blank sheet of paper or a blank notepad on the computer and think of one data-driven process in your organization, anyone, and think about any bias in that data. Now, what I will promise you is that if there is data in that problem, then there is bias in the data. And if that data is about humans, then there is bias about humans in that data. It's just about uncovering it and then deciding, is this a large enough issue for me to take any additional action? Or is this acceptable? Do my end users understand and accept the risk here?
Yeah. So we really do need to question more. And we need better questions, and we need to wait for the answers and apply accordingly. Otherwise, we're going to keep repeating mistakes of the past, perhaps, as we bake them into the tools that we use in the future. My quick way of summing it up, I guess. Well, Charlene, thank you so much. Appreciate your time.
Yeah, thank you, Rob, for having me.
Absolutely. And Daniel, you as well.
Thank you for a great conversation.
Did you know that there are over 180 cognitive biases clouding our judgment, skewing our perception of reality? And left unchecked, they're going to embed themselves in the very systems that we rely on, making us prisoners of our past mistakes. And our tools now risk amplifying these flaws. Well, this has to stop now. We're all going through a continuous, urgent learning process right now. And in these defining moments for business, for government, for society, it's crucial that we support each other, that we avoid preventable mistakes. Now, you can read the paper that we talked about today, Mitigating Bias in AI using debias-GAN. It's got great details as well as references that may help you digest what we've touched on. But I want to point you toward this AI and data overview page because it's a great resource. Specifically related to today's show, I'd recommend papers like Policy Considerations for Responsible AI. Oh, but look, there's also Generative AI, Practical AI. You know what? Just click this follow button and we'll make sure we don't miss a thing. This page will only increase in value over time, so it's worth following because you're going to want to come back to it. But I'll close with this. The impact of AI on business operations can be unpredictable, but there is one guiding light we can always use to steer us back on course: data.
Artificial intelligence is one of the most compelling advancements in human history. It's fun to dream about the possibilities, the countless ways AI will transform how we work and play. But to fully harness the momentum and promise of AI, from exponential leaps in productivity and efficiency, to faster insights and fewer errors, to instant creativity and intelligent decision-making, you need a mature data strategy. At Worldwide Technology, we know how vital data governance is to the long-term success of AI initiatives. Whether you're developing your AI and data blueprint, modernizing your IT infrastructure to support the endless flow of data, or anywhere in between, we can turn your vision into reality. That's data designed to deliver.
Well, as much as I like reading and research, I just remind you, as much as I remind myself, don't let that distract you from just picking up the phone. Reach out and touch someone. Remember that? Maybe an AI expert from WWT. Worldwide Technology, they're very well poised to help you and your organization, regardless of how smart you may feel in these areas. Trust me. Activity and progress are completely different beasts, so don't get caught up in one or the other. We're in this together. My name is Rob Boyd. Thank you for watching.